Hi dear students, welcome back to Mathematics Online class. Previous class, we people have studied what is the function. Now, in this class, let us start with the types of the functions. What are the different types of the functions are there? Types of the function. Yes. Once again, revise the function. Definition of the function. What is a function? Let a and B are the any two non-empty sets and F is a relation. This relation is said to be a function. When it is said to be a function, whenever every element of the set A, every element of the set A has the one and only one image of the set B. Every element of the set A has one and only one image on the set B. Then this relation becomes a function. This is a definition, we know that. Now, and several how to recognize whether the given relation is a function or not, several tray diagram and as well as the roster form of the relation we people have taken. Now, next thing is types of the function. In that, first one is one function or injective function. One or a injective function. None of this. What is a one or a what is a injective function? So a word itself telling that one element has the one image. That is nothing but let again the same thing. Let A and B are the any two non-empty sets. A and B are the any two non-empty set. F is said to be a one function. When this F is said to be one function only when every element of or a different element have the different images. Different element have the different images. Each element of the when it becomes a function. Function means every element of the set A has a unique image. So has a one and only one image. Those all elements from the set A, all elements of the different elements of the set A has the different images. In such case, we can say that it is a one function or injective function. Are you sure about this one? Otherwise, suppose it is not a one, then it is said to be that mini one function. Otherwise, it is said to be a mini one function. What is a mini one function? Many element have the one image. Many element have the one image. Yes. Let us take a few ray diagram. Suppose this is set A, set B. Function I just chosen. This I just say that one is that A, B, C is that 1, 2, 3, 4. A is related to 1, B is related to 3, C is related to 4. Can I say that a given condition is satisfied here? Different element. First of all, is it a function? Yes, every element have the images. Different element have the different images. Therefore, obviously, we can say that F1 is a one or a injective function. Another ray diagram. So 1, 2, 3, 4, and A, B, C, D, E. 1 is related to A, 2 is related to B, 3 is related to B, and 4 is related to C. Whether it is a function, check it first of all whether it is a function or not, because F is a function is said to be one I just take it. So F2 should be a function. Yes, all the elements have the images. Obviously, it is a function. Now tell me, different element have the different images here. Observe that different element have the different images. No, here two different elements have the same image. Image of 2 and image of 3 is B. So that it is not a one function. So this is F2 is not one. Why? F3 is not one because different element do not have a different images. What I need? Different element have the different image needed, but different element have the same image, single image. Therefore, it is not a one function. Are you clear about this one? It is not a one, but it is a mini one because many element have the one image. Many element have the one image. Therefore, it is F2 is a mini one function. F2 is a mini one function. And one more thing, just clear that. Suppose F is a function from the set A into B is that. F is a function from A into B is that. And suppose A comma B, order pair A comma B is present in the function f. How to denote this one? F of A is equal to B. That we just give that image of A under the function f is what? B. F of A is equal to B. What is the meaning of this one? Image of A under the function f is B. This is exactly the meaning. Are you clear about this one? Already just taken that. For example, in this case, image of A under the function f1 is 1, image of B is 3, like that. This one only we can write f1 of A is equal to 1. Image of A under the function f1 is 1. f1 of B, image of B under the function f1 is 3. Image of C under the function f1 is how much? Is 4. This is how we have to write. So I think you clear about the one function. Once again, what is the definition of the one function? Very important definition. In one mark session, they used to ask that define one function. That's it. So what is the one? Let A and B are the two non-unit set. Then f is said to be a one function if different element have the different images. Different element have the different images is called a one function. Otherwise, it is said to be a minimum. What is a minimum? Many elements have the same image. Are you sure? Okay. This is the first type. Now, second type is onto or subjective. Onto or subjective function. What is the onto or subjective function? Onto function. So again, that is understood. Let A and B are the two non-unity set is considered. A and B are the two non-unity set. Then f is a function depend on these two non-unity set. Is said to be a onto function or a subjective function. When it is said to be a onto function, when the f is said to be onto function, if every element of the set B, if every element of the set B has at least one pre-image, has at least one pre-image in the set A, has at least one pre-image in the set B, is called as a onto function. Otherwise, it is said to be that. Otherwise, it is said to be that into function. And finally, just write down the definitions also. Okay. What is the onto function? A and B are the two non-unit set. On those two set, a function is defined here. How the function is defined here? Function is then every element that already function I am just telling. Next, that function is said to be onto function. When it is said to be onto function, a condition. What is the condition? Every element of the set B, second set, every element of the set B has at least one pre-image. Already know the images and the pre-image. Here, image of A under the function f1 is what? Image of B under the function f1 is 3. Image of C under the function f1 is 4. Similarly, pre-images. Image of A is 1. Image of B is 3. Image of C is 4. Pre-image of 1 is A, pre-image of 3 is B, pre-image of 4 is C. Similarly, pre-image of A is 1, pre-image of B is 2, pre-image of B is 3, pre-image of C is 4. Are you clear about this? Images and the pre-images. Now, to discuss the onto, they are taken a pre-images. What is the pre-image condition? What is the condition? If every element of the set B is nothing but second set. Every element of the set B, every element of the set B has at least one pre-image. Minimum, it should have the at least minimum one image it should have on the first set A. In such case, we can say that it is a onto function. Yes, particularly. Otherwise, it is said to be that into function. Suppose A is that, B is that. Suppose here I just consider f3 is a function. Just for a different name. 1, 2, 3, 4, A, B, C, D, E is the image of A is what? Image of 2 is B, image of 3 is B, and image of 4 is C. First of all, tell me whether it is a function or not a function. Very clearly observe that. Whether it is a function or not a function. Yes, Yes, obviously it is a function because every element have the one and only one image on the set B. Yes, obviously it is a function. First condition is satisfied. Next, check whether it is a one-one function. What is a one-one? Different element have the different images. Different element have the different images. No, different element have the same image. Therefore, it is not a one-one. It is a mini-one. Okay, it is not a one-one. Next, is it onto? What is the definition of onto? Every element of the set B, every element of the set B has at least one pre-image. ಕಡಿಮೆ ಅಂದ್ರೆ ಒಂದಾದರೂ pre-image ಇರಲೇಬೇಕು. ಕಡಿಮೆ ಒಂದಾದರೂ pre-image ಇರಬೇಕು. Has at least one pre-image. Okay. So every element of the set B has at least one pre-image. No, there are two elements D and E. There do not have any pre-image. Therefore, F3 is not a onto function. It is a into function. Okay. One more way diagram is considered. Suppose set A, set B is a function name is a F4. 1, 2, 3, 4 and A, B, C, D, E. 5 and the F is 1 is related to A, 2 is related to B, 3 is related to C, 4 is related to D and 5 is related to E. Now, and you can take that 6 is related to E. Now check it first of all whether it is a function or not a function. Function definition: every element of the set A has one and only one image of the set B. Every element of the set A has one and only one image of the set B. Yes, obviously it is a function. Check it very carefully definition. Next, whether it is a one-one function. Different element have the different images. Different element have the different images. No, here 5 and 6 have the same image. Therefore, it is not a one-one. Now check whether it is a onto function. Onto. What is the definition of onto? Very clearly, just remember the definition. Important. Okay. So, what is the onto? Every element of the set B has at least one pre-image. ಕಡಿಮೆ ಆದರೂ ಒಂದಾದರೂ pre-image ಇರಲೇಬೇಕು. Every element related pre-images ಅವ? Yes. ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಗೆ pre-images ಅದ. Every element has the pre-images. Every element has the pre-images is nothing but check it. E has the two pre-images. E has the pre-image 5. E has the pre-image 6. But our condition is what? At least minimum ಒಂದಾದರೂ ಇರಬೇಕು. Yes, nothing to worry. Obviously, F4 is a onto function. F4 is a onto or a subjective function. I think you got my point. How to decide that one and the onto. Very simple definitions are there. You just remember the words. Based on that word, you just check it. You get the idea. Different one element has one image. Onto every element of the code set has at least one pre-image. Yes, F4 is a onto function. Okay. Now, next third type is, what is the third type? Is bisective function. Bisective function. What is the bisective function? Again the same thing. Let A and B have the two non-empty sets. A and B are any two non-empty sets. Then F is a function depend on those two sets is said to be a bisective. When it is said to be a bisective, it is said to be a bisective if it is both one and the onto. Function is both one and the onto. Suppose the function is both conditions satisfied. One is there as well as onto is there. In such case, we can say that a given function is a bisective function. So these are the very three types of the function, very important for the examination point. Okay, they will ask the 5 marks question. They should give one function and check whether it is a bisective or not. So that very clearly remember the definition. Don't confuse it. Just if you get the confusion, read the sentence and refer the ray diagram. You can easily decide it. I'll just give the ray diagram whenever it is satisfying and not satisfying. So just compare it. Why it is not satisfying, when it is not satisfying. Just compare the things, we'll get the result, or we'll just get the point, how to remember the things. Okay, anyway, are you clear about the one and the onto? Just better to note down the definitions, very important. Okay, now based on these three definitions, let's move for the example. Once again, one. different element of the different images. That's all. Onto every element of the codomain set has at least one pre-image. That's all. Bisective function is both one as well as the onto. That's all. Is said to be a bisective function. Now, based on these types of the functions, let's move on the examples. We just pause the video and note down the definitions and as well as the array diagram according to the words. Just note down this. Now, let's move for the example. Show that the function is from n into n. Show that the function f is denoted by n into n is given by f of x is equal to 2x is 1 but not 1 is 1 but not 1. So they given a function. That function we need to prove that it is 1 but not a 1. For better understand what I just take it means, I just take an array diagram. So function is defined from where function is defined from natural number set to the natural number set. Just take it. Just for your understanding purpose, I am just writing the array diagram. Okay. N into n, domain and the codomain set are the natural number set. Natural number set is nothing but obviously 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and continues. Similarly, codomain set also same thing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 like that continues. Okay, in final series. Try to get the images of each element. Images of each element means what is the image of one? Image of 1. How to get the image of 1? Function already defined. What is the function value? F of x is equal to 2 times of x. Just replace the x value as 1. If I replace the x value as 1, what happens? F of 1. Wherever x is there, replace the 1. What will get? 2 will get it. Okay? F of 1. That means image of 1 is what? Image of 1 is 2. Similarly, F of 2. Image of 2. 2 2s are 4. Image of 2 is how much? 4. Image of 2 is 4. Next, image of 3, 6. Image of 4, 8. Image of 5, 10. So on it continues. First of all, every element of the domain set has the images. Yes, obviously. Whatever the natural number, you just take it, multiply by 2, that has the image. Obviously, every element has the images. Obviously, it is a function. Okay. Now, we are required to check that whether it is a 1. I am going to prove that it is 1 but not a 1. What is the definition of a 1? Different element of the different images. Yes, check it. Different element of the different images. Any two element of the same image? No. So different element of the different image. So from the array diagram, we got the conclusion. We just got the hint that it is a 1. Okay, correct. Now check it onto. Whether it is onto. What is the definition of onto? Every element from the codomain set has at least one pre-image. Codomain set ಒಳಗೆ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ pre-image ಇರಬೇಕು. At least one other pre-image ಇರಬೇಕು. ಅದಾವ check it. There are few numbers which do not have any pre-images. What are those numbers? Odd numbers. 1 do not have any pre-image. 3 do not have any pre-image. 5, 7, 9 and so on. Odd numbers do not have any pre-image. But it is sufficient to say that. Counter example. What is a counter example? Where the mathematical statement is fails, there we need to do the particular example, number example. That is said to be a counter example. But here 1 do not have any image, therefore it is not a onto. Just by counter example method, we can easily decide that it is not a onto function. Are you clear? Here, that one only we need to express, because show that we need to show. Okay. So here, one method is that I am just going to prove algorithm. Just follow the algorithm. How to prove the one means method? I just say that contradiction method. What is that? So I just consider two elements. What are the two elements? I just consider x1 and x2 belong to the n. x1 and x2 belong to the here. These are the two different elements. Just process is just remember how to put is a one. Definition we know that ray diagram from the ray diagram you can easily decide that one are on. But how to express mathematically, that is algorithm adjustment method, standard method you can follow it the same. Whenever they ask any function you can follow this process. First of all, consider two different elements. Those are must be present in the domain set. Very clearly observe it. After that, I am just consider what I just consider f of x1 is equal to f of x. F of x1 is equal to f of x2. I just consider. What is the meaning of this one? Means image of x1 under the function f, image of x2 under the function f has the same image. I am just telling. What I am just telling, image of x1 and x2 different elements have the same image. I am just telling. On simplifying, if I got the x1 is equal to x2, whatever the different element are there, those are not a different element, those are none other the same. That means single element. So we can say that it is a 1. In case 1 to the n to f is 1. Suppose x1 is not equal to the x2, then we can say that f is not 1. Why? Those are not a different. Those are a different element. Have the same image. Different element have the same image. These our condition of 1 definition is not satisfied, therefore it is not a 1. Just remember that. So just write it. Simplifying, if we got x1 is equal to x2, then conclude that f is 1. If we got x1 is not equal to x2, then conclude that f is not 1. Okay. Now proceed. How to get the x1 is equal to x2 or x1 is not equal to x2? Okay, f of x1 is equal to f of x. I just consider how, what is this method? This method we just say that contradiction method. So in the first syllabus, mathematical reasoning is that, but actually for this 2021 academic year they have deleted unfortunately. Anyway, so just remember f of x1 is equal to f of x. What is f of x? 2x. Wherever x is that x1 to x1, f of x2 is nothing but 2x2. Can I cancel the 2? Yes, x1 is equal to x2. We got that x1 is equal to x2. x1 is equal to x2 is nothing but what we need to conclude that f is a 1 function. Every problem we have to proceed in the same way. Mathematically we have to simplify. Okay, now f is 1. Conclusion is over. Now for onto go for the onto. Here by the counter example method already just explained that. So any element let 1 is belong to the natural number set. This is from the codomain set which do not have any pre-image. Which do not have any pre-image. Which do not have any pre-image. Therefore also f is not 1. So f is not. That's all. Hence, final conclusion. What is the final conclusion? Hence, f is 1, but not on. But not on. Hence, our solution is over. So here, for proving another method is that, I just taken the another method onto. Here, by giving the counter example, we have decided that f is not a onto function. Different algorithm. What is the algorithm means? So for onto another method I am just telling, whenever there are some different lengthy questions are there which is not able to get the ray diagram, in such case how will do? Here ray diagram is not required, obviously we can decide it, and here due to the ray diagram we just got it. Suppose if you are not able to get the ray diagram, in such case how will you get it? For onto, let any element y which is present in the codomain. Consider one element. What is the definition of onto? Every element of the second set which has at least one pre-image. Okay, I just consider one element which is from the codomain set. Here codomain set is the natural number set. Let y is belong to the codomain set n. Then if f of x is equal to y, if f of x is equal to y set. Now here replace the f of xi or y is equal to f of xi. Just write it. So now y is equal. What is the value? y is equal to f of x. F of x is nothing but what? 2x is there. Here y value in terms of x is there. Y value in terms of x, that is 2x is there. Now try to get the x value. What is the x value? Simplify. X is equal to what we can write? Y divided by 2. That is nothing but y has x has the image under the function f as y. Now I need the pre-image. How to get the pre-image? X is equal to, that means y is equal to in terms of x is there. Now get the x is equal to y by 2. This element whether is present in the domain set or not present in the domain set. Check it. So whether x is equal to y by 2 is present in the domain set or not present in the domain set, provided that y is what? Y is any natural number. If I replace y is any natural number, for example 1, y value is 1, 1 by 2, 1 by 2 is a natural number. No, 1 by 2 is not a natural number. X is not belongs to n. X is not present in the domain set. X is not present in the domain set is nothing but it is sufficient to conclude that f is not onto. What is the exactly meaning of this one? Means y is there in a codomain set and we have assumed that image of x under the function f is y. But this x is not present in the domain set. This x is not present in the domain set. X is not belong to n. Y belongs to n. Codomain y adakku ಯಾಕೆಂದರೆ y image of x under the function f is y assume ಮಾಡ್ಕೊಂಡಿ. But ಏನದು x domain set ಒಳಗೆ ಇಲ್ಲ. There is no x present in the domain set. Therefore it is not on. This is how exactly the meaning and this is how we have to prove mathematical algorithm. We can say that general process ಈ ರೀತಿ ಮಾಡಿ. Are you clear about this one? Very simple. Let y is any element belong to the codomain set. Consider that f of x is equal to y. Then replace the f of x value. Y in terms of x is that. Try to get the x value in terms of x. If we got x value in terms of y, then we can check whether it is present in the domain set or not present in the domain set. Then we can easily, if present, then it is onto. If not present, then it is not onto. Now let's move to the next example. I hope you will have clear how to check the 1 and the onto. I just given both according to the diagram as well as algorithm also I just given it. Now let's take it. Now the same problem little bit change. Prove that the function f is from r into r is defined by f of x is equal to 2x is defined by f of x is equal to 2x is 1 1 and the 1 is 1 1 and the 1. Here previous problem and this problem, what is the difference between the previous and this problem? Only thing the domain and the codomain changes. Previously natural number into natural number were there. Here is real number into real number is there. So in such case we will get the 1 1 as well as the 1. Whenever natural number, domain and the codomain are natural number where there it is 1 1 but not a 1 2. But domain and the codomain are real numbers are there. In such case it is satisfied both 1 1 and the 1. Yes, just get one ray diagram. What is the ray diagram? What is the domain and the codomain set? Real numbers are there both. Okay, 0 1 2 3 4 5 6 on up to -1 -2 -3 -4 so on -5. Here also 0 1 2 3 4 5 6 7 8 9 10 so on. Not only these numbers, still so many numbers are there. I just consider only these numbers. Okay, here 1 point, several there are infinite set both. Okay, and just consider few examples just. Okay, try to get the images. What is the image of 0? Wherever x is there, replace 0. Image of 0 under this function is 0. Image of 1, f of 1 image is 2. Image of 2 is 4. Image of 3 is 6. Image of 4 is 8. So on it continues. Similarly, image of -1. X is that -1 replace. Image of -1 is -2. Image of -2 is -4. Image of minus 3 is minus 6, so on. Can I say that every element of the domain set has the images? Yes, obviously it has the images. Now I need to prove that both one as well as the onto. Check it. Do you have onto means one is clear, different element have the different images. What about the onto? Every element have the three images. Very carefully answer. Every element have the three images. Yes, every element have the three images. We can arise the doubt. Where is the pre-image of 1? Where is the pre-image of 3? Pre-image of 1 means, can I take the 1 by 2? In a domain set, 1 by 2 is there. What is the image of 1 by 2? Image of 1 by 2. 2 into 1 by 2. It becomes a 1. What is the image of 3? What is the pre-image of 3? 3 by 2. Wherever x is there, replace the 3 by 2. 2 to get cancelled. Image of 3 by 2 is 3. Whatever the number is, take all the element. Pre-image of 5 is 5 by 2. Pre-image of 7 is 7 by 2. Like that. So every element has the pre-images. Are you clear about this one? From this, okay, obviously. Now, mathematically, we have to prove that this is 1 1 as well as the 1 2. That is nothing but bicycle we need to prove it. Okay. So I have already given the algorithm for a 1 1. Mathematically, we need to prove that. How to prove? Let x1 and x2 belong to the domain set. You just clearly understand and remember the steps for one problem. One problem, just clearly observe. The same method we need to proceed for all the problems. Okay. x1 and x2 are the present in the domain set. Consider. I am just considering that image of x1 and image of x2 under the function f is the same. Okay. What is the f of x1? That is nothing but 2x1. F of x2 is nothing but 2x2. 2 to get cancelled. x1 is equal to x2. Therefore, we can say that f is a 1 1 function. F is a 1 1 function. Okay. Next. Over. Now for on. What is the onto? General method we know that here it is already given conclusion or we have already got it. It is a onto function. Mathematically we have to prove that. That is let y belong to the codomain set R. Y belong to the any element which is present in the codomain set R. So if f of x is equal to y. What is the f of x is equal to y? That means y is equal to f of x. Y is equal to f of x value. What is the f of x value? 2x is that. 2x is nothing but we can write f of x is equal to, got to write in this way. So I just write f of x is nothing but 2x is equal to y. Y value in terms of x. We need the x value in terms of y. X is equal to y by. This y is any real number. If I replace here, then x value will come. This x value present in the domain set. Real number or not present in the domain set. Y is any real number divided by 2. Obviously, it is present in the domain set. That is c, which is also a real number. Therefore, we can conclude that f is a onto function. That's it. We are required to prove that 1 1 and the onto. Hence, we just got the result. F is a 1 1 and onto. That's all. Okay. Sometimes to test the question paper in examination, what they used to ask me is, instead of asking the proof that, they will ask that check whether it is a 1 1 and the onto, or determine whether it is a 1 1 or a onto, or check whether it is a bisector or not. Justify the answer. So just check and just clear about this one. Bisector to kelbodu 1 1 onto separately they might have asked it, or instead of 1 1 injective and the subjective also they might have asked it. So process already know that. If you got the ray diagram, easily conclusion will get it. If you don't get the ray diagram also, we can easily decide it. Mathematically, we just simplify, we will get the answer. Now, I hope people are more convinced with this problem. Now, better to go to the next example. Okay, take the next example, third example. Show that the function f is from R into R. Show that the function f is from R into R is defined as f of x is equal to x square is neither 1 1 is neither 1 1 nor 1 is neither 1 1 nor 1 2. So what we need to prove here, show that the function f is given r into r defined as f of x is equal to x square is neither 1 1 nor onto. Neither 1 1 nor onto is nothing but it is not a 1 1 not a onto. We are equal to prove it. Yes. Again the same thing. We can get the one ray diagram, then we can easily get the conclusion whether it is a 1 1 or not a 1 1. Later you can proceed it mathematically or else you just proceed. Just for a beginning stage you have, so better to get one ray diagram. You get the conclusion how to decide it. Then proceed. You just pause the video, try to solve it. Okay. Now I just directly write the, just for understanding purpose, what is the domain set? Codomain set. Set of real number to set of real number is that. Consider the equivalent. What are the equivalent? Real numbers are there. 0, 1, 2, 3, 4, 5, 6, 7, so on, and minus 1, minus 2, minus 3, minus 4, so on. These are all the real numbers in the domain set. Similarly, codomain set 0, 1, 2, 3, 4, 6, 7, 8, 9, 16 like that. Here also minus 1, minus 2, minus 3, minus 4, so on to negative. Now try to get the images. Just writing for your better understand. Okay. Now image of 0. What is image of 0? Wherever x is there, replace 0. 0 square is 0. Image of 0 is 0. What is the image of 1? 1 square is a 1. Image of 1 is 1. Image of 2, 2 square, 2 square is a 4. Image of 3, 3 square, 9. Image of 4, 16. Like that is that. Similarly, what is the image of minus 1? Replace that. Minus 1 square. What is minus 1 square? Is a 1. Image of minus 1 is 1. Image of minus 2 is a 4. Image of minus 3 is a 9. Image of minus 4 is a 16. Are you sure about this one? Now, tell me. First of all, obviously it is a function because every element has the images function. Now, check. Now, tell me whether it is a 1 1 on seeing the ray diagram. 1 1 means different element have the different images. No, different element do not have a different images because two elements have the same image. Image of 1, image of minus 1 is 1. Image of 2, image of minus 2 is a plus 4. Image of 3, image of minus 3 is plus 9. Image, two different elements have the same image, therefore it is not a 1. Yes. On to definition what? Every element from the codomain set has at least one pre-image. One other pre-image. Do you have that? Every element from the codomain set has at least one pre-image? No. What are the elements which do not have pre-images? The negative real number do not have any pre-image, therefore it is not a onto. Are you clear about this one? Now let's prove mathematically. That is for 1 1. What will say about the 1 1? Let x1 and the x2 belong to the domain set R. This is the domain set R. Now what we have to get, that is so here x1 x2, consider f of x1 is equal to f of x2. F of x1 is equal to f of x2. Every problem has the same method. Okay, replace the f of x1. That means x1 square is equal to x2 square. X1 square is equal to x2 square. Now, can I cancel the square and write it as x1 is equal to x2? No, which is not possible. Why? Because suppose x square is equal to 4 is that. Then what is this written? X is equal to plus or minus 2 is this written. Are you sure about this one? How do we get this plus or minus 4 is nothing but this we can write x square is equal to 2 square. Then x square minus 2 square is equal to 0. Take that 2 square to left hand side. A square minus b square. What is the value? A plus b, a minus b. X minus 2 into x plus 2 is equal to 0. Product of two number equal to 0. Any one of the number is 0. Either x minus 2 is 0 or x plus 2 is 0. From this, either x is equal to 2 or x is equal to minus 2. I got it? That's why it is written the x is equal to plus or minus 2. Are you sure my point? In the same way. and here real number to real number is there. That's why we have tried the plus or minus. Suppose x1 x2 are real numbers are there. That's why we can get the either plus or minus, because minus 2 square is also plus and plus 2 square is also minus 2 square is also 4 and plus 2 square is also 4. That's why. So that's why real number is there. In that case we get it. Suppose if they change instead of a real number, if they give one a natural number to the natural number, in such case it is sufficient to write directly x is equal to 2. Why? Because x1 and x2 both are natural numbers are there. Square root of the natural number will get, if it is a perfect square, obviously we will get the positive value, will not get the negative value. Very clear my point? Here in the relations as well as in the function, the sets are plays a very important role. If we change the set, the total result will be reversed, or total result will be changes. Very careful about the set, for important. Okay. Now here x1 square is equal to x2 square. According to this, x1 and x2 are real numbers are there. Directly I just write x1 is equal to plus or minus x2. From this, where we got x1 is equal to x2 or x1 is equal to minus x2. Both possibilities are there. Simultaneously, in a single situation which is taking the two different values, then we cannot say that it is not possible. So your is not 1. Your is not 1. Why it is not 1? Because x1 is not equal to the x2. x1 is not equal to the x2. Obviously you can say that here from this x1 is not equal to the x2. Therefore you can say that f is not 1. Why this x1 is not equal to x2? Once in the same situation, once it is equal to the plus x2 happening, and once we got the minus x2, so which is not possible. That's why f is not 1. Next, this is all about the 1. Next, go for the onto. What is the onto? Let any element which is present in the coordinate set R, any element which is present in the coordinate set R, consider if f of x is equal to 1, f of x is equal to 1, then replace the f of x. What is f of x? X per is equal to y. X per is equal to y. Then I need the x is equal to how much? What is x is equal to? X is equal to again a plus or minus of root y. Plus or minus of root y. Mathematically I am just going plus or minus root y. Then x is equal to plus or minus root y. What is the y value? What is the y value we need to choose? Y is any real number. If I choose y is any real number, then is it belong to the domain set R or not belong to the domain set R? Check it. Y is any real number, then x is a real number or not a real number? In some situation, it is not a real number. Where it is not real number? For y is a negative value. For example, if I place y is equal to minus 2, root of minus 2. Root of minus 2 is nothing but imaginary number, complex number will get it. Are you clear about this one? Square root of the negative quantity, imaginary number will get it. So that it is not belong to the real number. I got it? How to conclude it? Therefore, f is not 1. F is not 1. F is not 1. Are you sure about this one? Suppose instead of this one, another way. Counter example. Give a counter example. What is a counter example? Which element do not have a pre-image? Just give it. What is that? Or another method for onto. What is the another method for onto? Any one element which do not have a pre-image. Just give it. There are so many numbers which do not have a pre-images. That what are those? Minus 2 is belong to the codomain set which do not have any pre-image. Right now. Minus 2 which do not have any pre-image, therefore it is not a onto. Either in examination, either you can do this part for onto or else you can do this part. You will get the same. You will get the marks. Are you sure? So just write minus 2 belong to the codomain set, but it do not have any pre-images. Therefore, f is not onto. Hence, final conclusion. What is the final conclusion? F is not 1 1 not onto, so that neither 1 1 nor onto. F is neither 1 1 nor onto. Are you clear about this one? How to check? Hello? Yes. Good. Keep it up. Now let's go to the next example. Okay. So better I just stop here. In the next class, I just continue the problems based on that, how to prove the 1 1 and the 1 2. Okay.